Olá pessoal, estamos ao vivo para mais um Café com Embarcados, aquele momento que a gente para as atividades aqui no Embarcados e vem bater um papo com você, sempre trazendo aí convidados muito importantes na nossa área. Tudo bom, Fábio?
Beleza, Thiago? Beleza, pessoal? Isso aí. Voltamos com o café. Semana passada não teve. Acho que na outra semana também não teve. E estamos de volta aí agora com um super café hoje aqui. Falar sobre Linux, né? Vamos receber o Ricardo e também Fernando, Luiz Cola. Vamos falar aqui de Linux e também falar bastante de container em Linux.
Exatamente, Fábio. Eu estou muito ansioso aí para esse programa. A gente recebeu o Ricardo Mendoza, ele está lá na Espanha, eu acho. Ele é da Espanha e a gente vai conversar com ele ao vivo daqui a pouquinho. O Fernando vai ajudar a gente aí com toda essa curadoria. O Fernando que está à frente aí de um curso de Linux embarcado e de Octo também aqui na plataforma do Embarcados.
Isso aí, pessoal. Então aproveitem aí, porque o Ricardo tá lá, já é de noite. Já estava na hora de dormir, ele vai dormir mais tarde hoje só para falar com a gente, hein?
Exatamente, Fábio, exatamente. Então a honra recebê-lo aqui, Ricardo que está à frente aí da Pantacor. Então vai ser bem bacana essa conversa.
Isso aí, pessoal. Então deixa já o boa tarde aí, vai deixando também de onde vocês estão assistindo e deixa aí também mensagens. A gente daqui a pouco dá uma boa tarde para vocês aí, nominalmente.
É isso aí, Fábio. Deixa eu passar rapidinho pelas novidades do Embarcados. Pedir para o pessoal comentar aqui que ajuda a gente na live, tá? Seja no LinkedIn, seja no Facebook, ou se não, aqui no YouTube, tá joia? Então, deixa seu comentário, daqui a pouco a gente coloca vocês na tela. Beleza? Então, deixa eu compartilhar o Embarcados aqui e mostrar para vocês que o Embarcados está mudando todo dia, porque a gente recebe novos textos e publicamos. Muitos dos textos são enviados aí por pessoas que querem compartilhar conhecimento aí na área, né? Ontem tivemos um webinar muito bacana sobre DFM e projetos do mundo real, com soluções competitivas em conectores. Recebemos 4 especialistas e foi bem legal, né, Fábio?
Sensacional. Excelente. Para quem faz produto, se não passar por aquele webinar, com certeza vai ter problema na hora de escolher o conector.
Com certeza. Pessoal, é incrível, né? E o Alex, que está aí há mais de 20 anos na área, o Jorge está há 20 anos também, o Mike, que tem muito conhecimento sobre toda a linha de conectores, foi muito legal. E o Eduardo também, né? Que manja muito aí de Hirose e trouxe todas as novidades aí para o pessoal, né, Fábio?
Isso aí. Então é muito legal que o webinar foi parte em inglês, parte em português. Então assistam lá a gravação, quem perdeu. Quem assistiu, assiste também o replay. E aproveitem aí, façam conexão lá com o pessoal da Hirose, da TL, para eles suportarem vocês aí com conectores.
Fábio, aqui nos grupos de WhatsApp, né, o pessoal sempre reclama aí de que tem muita informação na internet, não sei o quê, mas se a pessoa parar 1 hora e meia, para assistir qualquer um desses webinars aqui, tem muito conhecimento compilado certinho numa ordem aí, bem bacana, né, Fábio?
É que tem muita informação, mas o muito não quer dizer que é boa, né? Uhum. Então aqui é legal que o webinar, você tem informação bem consolidada ali no assunto, né? Você pode entrar ali para assistir e o conteúdo geralmente quem passa é a pessoa especialista naquele assunto que está falando. Então não adianta ficar procurando muito. Eu acho que vai ali aí nesse hub aí, né, de webinars que você vai encontrar um conteúdo que provavelmente vai te ajudar em projetos ou, né, outros assuntos relacionados aí ao desenvolvimento de produtos.
Fábio, ó, e olhando aqui pelo que já aconteceu, né, esse ano, olha isso, são 13 webinars que já tivemos com bastante conhecimento em hardware, firmware, machine learning, IoT. Então, convidar o pessoal, ninguém paga nada para assistir esses webinars. Esses webinars aqui estão disponíveis, todos eles, você clica aqui, pode assistir o webinar gravado, tá? Essa é a ideia de vocês virem participar. E a gente convida vocês sempre participarem ao vivo, tá? Então a gente sempre está postando em novos webinars. Tá? E nós vamos convidar vocês para o evento que a gente acabou de lançar. É um evento que vai acontecer no dia 30 de agosto. Vai ser um sábado, o dia todo. Começa de manhã e vai até a parte da tarde, com diversas palestras com especialistas. São 7 palestras durante esse seminário Linux embarcado. Tá? vai ser então no dia 30 de agosto. Coloque na agenda, inscreva-se agora. As vagas são limitadas por conta de limitação da plataforma, tá? Então a gente convida vocês a se inscreverem já e ficarem aí prontos para receber todo o conhecimento. Os 4 palestrantes já estão confirmados: Otávio Salvador, Diego Sueiro, Cleiton Bueno, João Newton, Henrique da Rosa. Todos os 4 aí especialistas em uma parte diferente do Linux, né? O João Newton vem falar de hardware, o Cleiton vem falar sobre segredos para começar aí com Linux embarcado, né? Algumas dicas também. O Otávio Salvador vem falar sobre Yocto e o Diego vem falar sobre Yocto na prática. Então nós teremos aí mais 3 palestras, né? Uma palestra com ST, outra palestra com a NXP e uma palestra com a Quectel também, além de uma palestra com a Mouse Electronics. Então vai ser bem bacana, trazendo aí conhecimento técnico para vocês na área de Linux embarcado. E nós já confirmamos aqui, no mínimo, 6 dev kits serão sorteados, Fábio. Eu não tenho ainda o número exato de dev kits, mas já temos mais de 6. Então já podemos garantir aí que teremos muitos sorteios de dev kits na área de Linux embarcado, tá? Inclusive na minha mesa.
Durante o evento.
Durante o evento.
Tem que estar participando do evento ali ao vivo para ganhar.
Exatamente.
Gratuito, pessoal. Se você, ano passado, não conseguiu ir no presencial, que é mais difícil, esse ano não tem desculpa para não participar. Então, vai lá, garante sua inscrição ali já e venha participar. Inclusive, teremos palestrante internacional. Diego Sueiro vai palestrar. Diego, que faz tempo que não aparece aqui, vai aparecer exclusivamente para vir fazer uma palestra. E vai ser bem interessante porque ele vai falar da área automotiva. Então, aproveitem, assim, um evento bem legal. A gente conseguiu esse ano fazer online, né, para levar o conhecimento para mais pessoas aí, e vai ser bem interessante.
É isso aí. Então, se você se interessa por hardware de alta performance, por Linux embarcado ou Yocto Project, esse é o lugar, né? Então, vão ter diversas palestras. A gente ainda vai confirmar as palestras aí de ST, NXP, Mauser e Quectel, e nós vamos trazer aí para vocês certinho quais os temas, tá? Inclusive
volta lá
aqui...
na página, isso.
Tá, isso. Aqui, ó, a palestra da Quectel é com Juliano e com Maurício. Eles vão falar de desenvolvimento de aplicações de visão computacional em computação em borda para os módulos Smart. Então, Juliano e o Maurício estarão aqui também, já confirmados, né, para esse evento. Então,
abre aí, Thiago, para o pessoal ver como é que abre a descrição das palestras.
Aqui, ó, saber mais sobre a palestra. Aí você vai e lê cada uma das palestras, né, e seu tema certinho. Tá vendo? Tá aí, ó, o Diego trazendo desenvolvendo software vehicle, defined vehicle com o Yocto Project. Então, uma aplicação, tá? Com as ferramentas ARM. João Newton, segurança embarcada. O que meu hardware tem a ver com isso? O Cleiton, Linux embarcado sem dor de cabeça. Tá? Então, ele vem falar sobre a experiência dele, né? Ele já passou por muitos problemas de projeto, ele que está aí na área de consultoria, né? Otávio Salvador, que dispensa apresentações, né? Ele que escreveu aí um livro bem bacana com a Daiane. Ele vem trazer a palestra Boas Práticas no Desenvolvimento de Yocto Project, lições do campo. Tá? E aí, a gente tem com o Juliano Guarese e com o Maurício Alencar o desenvolvimento de aplicações de visão computacional em computação em borda para módulo Smart. A equipe ST está confirmando o nome da palestra e a NXP também está confirmando o nome da palestra. Tá? Então, vem participar com a gente gostaria de agradecer aí os patrocinadores, Mouse Electronics e Quectel, né, por promover aí e auxiliar a gente com toda essa preparação aí para esse evento, né, Fábio?
Isso aí, possibilitar que a gente leve esse evento de forma gratuita aí para todo mundo. Obrigado.
É isso mesmo. Então, obrigado a todos, obrigado aos palestrantes que vão vir aqui, né, também disponibilizar esse conhecimento, e gostaríamos da ajuda de vocês para divulgar esse evento, hein, pessoal? Então, daqui 16 dias, né, no sábado, sem ser nesse sábado que vem, no outro, tá? Dia 30, último sábado do mês, tá joia? E eu gostaria de promover aqui também, falar para vocês sobre o curso de Linux embarcado profissional com a equipe da MC Logic, que é a Bruna e o Fernando que estará aqui com a gente daqui a pouquinho, tá? O curso, aí, ele tem uma ementa bem atualizada, tá? Que aborda desde como configurar toolchains e cross-compiling, customização e otimização de bootloaders, geração de rootfs e BusyBox ou Yocto, acessar e gerenciar periféricos, né, diferentes periféricos com segurança e eficácia. Tem um desenvolvimento ali, um pouco de desenvolvimento com LVGL, também depuração de aplicações de sistema Linux, e, na verdade, eu até estava falando com o Felipe Neves, né, ele trabalha na LVGL, ele falou que essa parte aqui do curso é muito interessante aqui, com relação ali como fazer o setup, né? Então é um diferencial desse curso aqui do Fernando e da Bruna. Entender também sobre as licenças open source, como que isso impacta no seu projeto, na hora de fazer lançamento, né? E também algumas boas práticas para você não misturar licenças permissivas com não permissivas, além de containers para Linux embarcado em cenários de produção. Então depois dê uma lida aqui, com mais detalhes. E tem o projeto de final de curso também, que eles acabaram de lançar o projeto de final de curso. Tem um desafio para fazer, e isso vai provar o seu conhecimento aí na área. Claro que o projeto de final de curso, eles sugerem qualquer placa aí que vocês tenham disponível, por exemplo, uma Raspberry Pi, né, ou uma BeagleBone, um BeagleBone Black. Então, tá aí. Nós convidamos vocês a verificarem mais sobre esse curso, né, Fábio?
Isso aí, tá barato, hein?
Tá.
Acho que vai subir esse preço aí em breve, hein? Vai subir esse preço. Então, pessoal, aproveita, acho que agora é o melhor momento. Pega esse curso aí, aproveita, já pega também, vem no seminário, imersão em Linux aí, por esses dias. Depois vocês vão pro próximo passo, que é o Yocto também, que tá disponível lá para vocês também.
E eles terminaram de publicar todos os vídeos na plataforma agora em agosto. Então isso aqui tá fresquinho. Eu acho que a aula de containers foi agora em agosto, Fábio.
Então, tá tudo fresquinho aí.
Fresquinho.
Só aproveitar.
É isso aí. Agora com curso completão lá na plataforma. Então, você pode pagar em 3 vezes no cartão de crédito. É só entrar aqui na plataforma, conferir certinho a ementa, né? Para setar suas expectativas e dar o play nas aulas aí, né, Fábio?
Isso aí. E até aproveitando, né, que você falou ali, Thiago, no início o pessoal fala que tem muita informação. Na verdade, eu nem tô vendo isso aí também, porque eu tô cortando um monte de informação. Mas assim, não tem desculpa para você falar que não tem uma formação de Linux hoje, ó. Tá aí, ó, disponível. Você pode comprar, acessar agora e fazer no seu ritmo aí. Então, tá disponível, você pode tirar suas dúvidas e tal. Então, assim, é importante ter esse material bem linear, porque você vai do início, né, dentro ali do objetivo do curso, e tem o suporte dos professores e vai fazendo sua formação ali para ganhar tempo, eliminar também essa, igual o Thiago falou aí, de muita informação sem qualidade, né, por aí.
Só o tópico 9, Fábio, ou o tópico 13 sozinho, já é um módulo de um treinamento completo. Então tem muita informação bacana aqui.
Mas só o primeiro já ajuda, né? Porque é a base.
É a base.
Tem que começar baby steps. Isso aí, pessoal.
Exatamente.
Beleza?
Mostrando era isso? Aqui, ó. Um dos 5 brindes já estão aqui na minha mão.
Mas isso aí o quê?
Isso aqui será sorteado durante o seminário Linux Embarcado.
É do outro assunto. Beleza. Tem mais algum recado, Thiago? Porque o tempo tá passando aqui. Precisamos fazer o nosso... Você falou da placa?
Tem um último recado aqui. Tem um último recado aqui da plaquinha da NXP. Deixa eu mostrar aqui, pessoal. Eu acabei me empolgando aqui no treinamento e fiquei por essa. Tem uma plaquinha que chegou, novidade na mouse, que é uma Freedom Board MCX E247. Está aqui a fotinha, né, daquela Freedom Board. É com um microcontrolador que tem um Core M4F, tá? E ele tem diversos dispositivos aqui que está pronto para você utilizar. Destaque para 3 CANs, CAN 1, 0, 1 e 2 aqui em cima, tá? Diversas conexões, claro, PMOD, microbus, só que aqui, Fábio, tem um acelerômetro também. Aqui um acelerômetro pronto para usar, tem uma QSPI Flash também, tá? E claro, pronto para você avaliar aí o MCX e 247, que é uma MCU da NXP. Então, mais essa novidade, vou deixar o link aí para o pessoal acessar, beleza?
Beleza, pessoal, dê uma olhada. Aí já é outro universo, né? Foge um pouco do Linux, mas é importante, inclusive, essa placa dá suporte a todo o ecossistema ali da NXP e também, se você quiser desenvolver com o Zephyr, também dá para ir.
Exatamente. Deixei o link aqui pro pessoal.
Beleza. Bora lá, então. Boa tarde aqui pra galera. Vamos ver quem tá participando aqui. Pessoal, daqui a pouco a gente vai mudar a chavinha aqui pro inglês, tá? A gente fez essa introdução aqui agora em português para receber vocês. A gente vai fazer aqui o webinar, o café em inglês. E fiquem à vontade a interagir aqui. Pode interagir em português, inglês, do jeito que vocês acharem melhor. Ó, Adriano tá aqui com a gente. Boa tarde, Adriano. Marcos, boa tarde, Marcos. Guilherme, boa tarde, Guilherme. A Bruna, boa tarde, Bruna. Eduardo tá aqui também. Vinícius, valeu, Vinícius, boa tarde. Isso aí, André Mesquita também, boa tarde. André vai gostar aqui, vai falar de container, hein, André? Você que gosta bastante. Juliano também tá aqui, boa tarde. Marcos Lage, diretamente do Rio Verde, Goiás. Boa tarde, isso aí. Ó, o Fernando tá aqui, daqui a pouco entra com a gente aqui também. Evandro, olha, evento de sábado, hein? Para você esse evento, hein? Isso aí. Edmilson também tá aqui, boa tarde. Jorge, boa tarde. Robert, fala, Robert.
Grande Robert.
Robert que tá agora, voltou, tá ativo lá no LinkedIn agora, fazendo bastante conteúdo. Acabou de fazer a inscrição. Isso aí, pessoal. Então aproveita e faça a inscrição aí, como o Adriano fez. Professor Roger. Isso aí, professor. Olha lá, fez rapidinho aí. Diogo também tá aqui, boa tarde. Marlon. Eduardo. Isso aí. Rogério Silva, seminário grátis. Isso aí, grátis. Grátis para todo mundo vir e não tem desculpa, hein? E o conteúdo vai ser conteúdo top, hein?
Vai.
Isso aí. Dev Eco, boa tarde. Fernando também tá aqui. Boa tarde. Beleza? Tá aqui. Tá assistindo no LinkedIn. Ah, é o Robert. Fala, Robert. Isso aí. Come to Brasil. E o Andrei também tá aqui. Andrei diretamente do Pará, né? Seja bem-vindo, Andrei. Isso aí, Thiago. Bora?
É isso aí, Fábio.
Muda a chave.
Vamos nessa, vamos mudar a chave. Vamos convidar para a sala, então, o Fernando Cola e Ricardo Mendoza. Ricardo, welcome to Brazil.
Thank you.
Yeah.
Thank
Hello,
you.
guys.
I tried to follow as much as I could of what you were saying, but you guys speak very fast.
Okay, let's go. Let's start the podcast. Ok, Thiago.
Ô, Ricardo. Yes. First of all, thank you very much for being here today. I would like you to introduce yourself in 1 minute.
In 1 minute. Okay, well.
Yeah.
All right. First of all, thank you for having me, guys. Of course, it's great to talk with this community. Like in my mind, I've always thought that Brazilian and embedded Linux developers are like the top that nobody knows about, right? The world is a big place, and Brazil is full of the smartest people in the embedded Linux world, I think. And sometimes when you really talk to like big industry, not everybody is aware, and it's weird, right? They don't know that the whole thing is built on top of Brazilians. But to introduce myself, that was already 1 minute, so maybe 1 more minute. So I run Pantacor, right? So Pantacor, we'll talk about that in a minute, right? But I personally have a long background in embedded Linux, all the way from early 2000s, working with MIPS Linux, porting some kernels and doing maintenance for SGI, Silicon Graphics machines, early in the days of those sort of like, not off-brand, but secondary architecture communities, right? They were not the biggest back then. Everything was about x86 at the time. But embedded Linux was starting to pick up. It wasn't very commercial at the time. It was more hobbyist. but it really set the ground for everything, right? After that, I spent a long time continuing to do MIPS Linux work, and as part of being a Gentoo developer, and then I moved on to other things, and eventually landed in Canonical, doing a lot of different work for all kinds of devices, basically everything from the phones and the tablets and all of those stacks at the time. Basically, I was part of multiple teams there, bringing different products to market, and then we went to found Pantacor back in 2016. So that's my 1 minute introduction.
Wow! So you worked on Canonical on Ubuntu?
Yeah, I did for about 4 years or something, 5 years. In the 2011, 12, around that time, I was there working with the different teams of very smart people, some extremely smart Brazilians as well, that were working on basically trying to bring Ubuntu to devices, right? So all the early experiments that eventually resulted in like Ubuntu Phone and tablet versions, and then things like Ubuntu Core and all those things. But later at the end of my tenure in Canonical. But yeah, lots of device work over at Ubuntu.
Okay, thank you. So to kick off, can you explain the Pantacor and its solution simply?
Simply, I mean, I don't like these questions of 1 minute. Simply, it's like quick fire, right?
Take your time.
Take your time.
So, all right, no, but simply put, the Pantacor just brings a paradigm shift in how we do embedded Linux software deployments. Instead of doing monolithic software, we bring a paradigm of using containerization not only for the application stack, but actually to manage the entirety of the firmware that is running on the device, right? Not only the application, but also the underlying system components. We basically do away with the idea of a main operating system, and instead every function of the system is containerized, right? There is no main stack. There isn't anything that first boots and brings up, your networking or everything. But instead, it's just a very, very thin layer of software that sets up your root namespace, let's call it, as a container. So to put it in little words, imagine any normal Linux system, embedded or not embedded or whatever, right? If all you have is one single userland, you're running in what is called the root namespace, right? The root namespace is just the kernel's own way of running you in a container for all intents and purposes. It's just that you don't realize it, right? We take that concept one level further and we say, well, there is no root namespace. There's only namespaces for the different functions of the system. As such, you can architect every system in a full software-defined way without having that sort of like two levels approach of having a base OS and then containerized applications on top. Instead, we just have containerized system modules, and that's what it is, right? Pantacor and our products, Pantavisor and Pantacor Hub, basically give you the ability to realize a vision of management of connected devices at scale with modular software deployment and with full open source solutions. Is that
Very
good for 1 minute again?
Yeah.
Thank
I think
you.
it was 2 minutes.
Okay, Ricardo. Pantacor is a company that values open source, right?
Yes.
What's the day-to-day dynamic like for your developers? How do they engage with and contribute to open source communities?
Well, I mean, so our products, I guess the cornerstone is that our products are open source, right? By definition, right? So with Pantavisor and Pantacor Hub and the different components in between, they are some of them are MIT licensed. So for the device side of software, Pantavisor is MIT licensed, and everything on the cloud is Apache licensed. So it's very permissive, right? So that's from our own company ethos. Everything we do is open source and with open source tools, right? But that's just that just comes from muscle memory pretty much for myself and my co-founder, Alexander Sack, right? And our team, it's interesting because a lot of the people in our team, except of course Fernando, right? Some people in our team didn't used to be very familiar with open source early on when we started, right? So it was interesting to see how we, pushed our developers to change into a complete open source work model, right? Once they are there, I think an open source model inside of a company that is developing products is very powerful, because it really lets you move fast, right? At the end of the day, the working in the open is it's like a wildfire. Fire spreads very fast, right? Just with the wind, right? And I think that's the same thing that happens with open source development, right? People just go and they go into whatever they want, right? The openness of open source also empowers developers to feel like they can just go and contribute in different areas, even if it's not a task at hand, right? If it's not a customer request or something like that, it's just going to go and try and make it better, right? In addition to that, of course, then we've pushed our team to engage deeply in the communities that power some of the subcomponents that we use in our products, right? Things like LXC, or, well, of course, the kernel as well, different components for, the kernels for different SoC vendors and so on. So there's a lot of back contribution there. Maybe, as far as our stack goes, it is true that, Pantavisor itself and Pantacor Hub are mostly in-house, right? So, we are, in this case, we're an open source company, but we're not an open source consultancy company. We're an open source product company, right? So, it's not like we're contributing to 50 different projects. We contribute to the project we use, right? But they are, a handful at best. But I think what I'm trying to say here is open source, I don't see it like just a badge to have, right? It's just a mentality, right? It's just how you work, right? I mean, if you can get your developers working in the open and openly sharing branches with each other, and even if it's inside of the same product or project, right? If the fact that things are open at the core makes collaboration shine, right? People just feel like, well, maybe at the beginning it's a little slower because people might sometimes be a little bit shy, right, into their contributions and what they can do. But once people are empowered to share with others and they see what they get back, the feedback that you get back from externals, that's a feeling that never gets old, like when you contribute something and you actually get praise for it, that never gets old, right? And I think that's really what it's about, right? That's what open source is about. It's about feeling good, right?
And it's difficult to understand that you have a model that works with open source, but your company is not open source, but you designed something that it's on the top of code of people, right?
No. Our company is open source as well. Our products are open source, right? Pantavisor, Pantacor Hub, everything is open source, right? It's just our model it's a slightly different model. Like we have Pantavisor itself is a fully open source project, right? Everybody can use it. Everybody can realize their own, device side architecture vision in whatever way they want with Pantavisor. We encourage people to use Pantavisor to create their product architectures. Pantavisor enabled devices can be connected to any backend that product operators might already have. There's an open API that they can consume locally to create, let's say, agents to handle updates, lifecycle management, and so on, right? And the reason for that is that, well, all of Pantavisor is open source, so you can really do whatever you want there. I mean, it's MIT license, right? So, for better or for worse, is a license that is more permissive for this world that we work in, right? I mean, you very well know that embedded Linux is not the same as, desktop Linux, let's call it, right? Desktop Linux, maybe the licensing fanatism is a little bit more aggressive than in embedded Linux, because in embedded Linux, well, it's a little bit more real world, right? In the sense that product differentiation matters, right? And the ones that are actually driving volume, the ones that are actually making those devices, care about their product differentiation, right? So certain licenses are a little bit more, exciting in this world, let's say, like MIT licenses. But to be very clear, right, the entire company is open source, right? Now, our business model around this, of course, is that we help support companies that want to realize their vision of next generation modular software architectures with Pantavisor. We support them, right? We're engineering force with long-term maintenance and support services and everything in between, right? There's all kinds of bespoke services that we provide to our customer base. However, we also provide a hosted version of our own Pantacor Hub product, right? Which is also open source, right? Pantacor Hub, if somebody wants to, let's say, launch a smart speaker or something that is using a Linux powered device, they can technically do it all by themselves, right? They could take Pantavisor, they could do their own port, they could take Pantacor Hub, they could get their own cloud infrastructure, deploy and control from that control plane without our involvement, right? Or you could just use our existing, scalable deployed solution for which you just pay by the unit connected or by actual utilization, right? This is a very, common model in the space, right? I think our main difference here is that we are making the core component, which is Pantavisor, interoperable with any other cloud management system that you want to have, right? In fact, most of our customers, right, end up using Pantavisor on their own with our support, right? But they use it on their own and they connect it to any existing device fleet management systems that they already have, right? Any big company will use their own thing, and we make it very easy for them to just leverage Pantavisor at scale, right? And I think that's where we differentiate from a lot of similar companies in the space. A lot of companies in the space are really just trying to sell you into using their cloud, right? That's not necessarily our play, right? We do sell our cloud mostly at the enterprise level to some customers that use it because, well, at the end of the day, we know how to do it best in that sense, right? And it's not their business model, right? But for those that actually want to own the own stack, the whole stack, we are more than happy to support them as well.
Okay, thank you for the reply. And Ricardo, we know that for IoT devices, security updates are very critical, especially because it gets very expensive if you make some mistake on this point. How do Pantacor, Pantavisor, and containers help solve some of these challenges? Solve or not solve, but to protect from these challenges, especially with remote updates?
Yeah, well, it really is all about remote updates, right? A remote update is an update that is consumed either from some kind of local agent that is then pushing an update to Pantavisor and it's talking to your cloud, or that is being consumed from Pantacor Hub, our own hosted instance. Now, Pantavisor is very interesting because, as I mentioned before, we define the whole system as containerized components. We don't have a base system running. There's only Pantavisor, which runs in the init ramfs. It's an init.rd basically bootable into it, and from there, every component of the system is started as a container. So it's a very small, very verifiable piece of software, right? That has a footprint of maybe 1 megabyte, or could even be made smaller if required, depending on the requirements, right? But because of the fact that we go all the way from root of trust to bootloader to our init, so the Linux kernel and our init.rd, right? And the init.rd then goes and starts container images, which are also very monolithic and verifiable. It is very straightforward for a Pantavisor-based architecture to implement a complete chain of trust across your boot, right? So in other words, what people call secure boot, right? Secure boot is one of those things that everybody has always talked about them, but there's like no one solution that fits all. And in reality, I remember 10 years ago, you would go into any of the top Linux vendors and they would be like, yeah, secure boot for embedded, we will solve that for you, don't worry, right? We have a solution for it. Then when you sit down with them, what you realize is that they give you a few architects and some big engineers that just develop something very bespoke for you, right? And it depends on the platform you're running on and so on, and it very much depends on the distribution you're using and how you build your distribution. Even with Yocto, like how you build your distribution affects the way that you would actually do a a validated or a complete measured or secure boot, right? In the case of Pantavisor, it's straightforward in the sense that we only have to measure a few components across the road, right? As long as you have a root of trust and you have signatures down the pipeline, then everything is fine, right? I mean, you have a root of trust, you can boot a validated bootloader. From there, you can boot a validated fit image, for example, and that fit image will have, signatures for kernel component, for your init.rd and everything. You boot into the Pantavisor binary that is in the init.rd, which was already verified because you verified the init.rd. Then Pantavisor loads the running state for the machine, which includes all of the container components that need to be started, right? Each and every one of those components is also signed and validated in the whole architecture of what we call the Pantavisor system state, which is what defines every single container and configuration for those containers that are running on the system. So from the point of view of security, I would have to say that we're very happy with the level of security that we have achieved in that we provide to our customers in terms of deterministic validation of what software is running out in every one of the connected devices that you are currently managing, right? And this is really what it's all about, right? It's being able to, when everything is working fine, then everything is fine. But when something goes wrong, you need to be able to say, well, actually, I can guarantee that the software that is executing is not tampered with, right? Or things like that. Or I can guarantee that if it gets tampered with, then that device is out of circulation. It can no longer talk to the cloud or vice versa, right? Things like that are very easy to achieve once you have a complete end-to-end, fully secure and validated boot chain, right? So I think that's where we focus most of our energy when it comes to security for over-the-air updates, right?
Thank you. Fernando?
Yeah, so I have two questions. So maybe we can talk about it a little bit. So why use LXC containers in Pantavisor? Because I think everybody's very familiar with Docker containers, especially people who work on desktop. So maybe talk a little bit about that.
I mean, I would first give a little bit of explanation, because not everybody knows what containers really are, right? Like, there's, for some people, there are still like this sort of like black box that happens over there, or weird technology, right? But containers, at the end of the day, solutions like Docker, LXC, or ROMC, or any of these kinds are just wrappers for base Linux functionality, which is a combination of namespaces, C groups, permissions, mount point. It's a combination for baseline kernel features. That's what I was saying earlier in the chat, that when in your laptop, in your computer, when you're running your server, when you're running a Linux distribution, a normal Linux distribution, let's call it, you're running in what is called a root namespace for all intents and purposes. But for the point of view of the kernel, it's like the whole system is a big container. It's just you're not aware of that concept, right? You're not aware of the fact that it's leveraging the same technology that you would leverage to run other parallel containers, right? What LXC or Docker do is that they wrap around these kernel features, kernel ABI features, to provide a user experience around it, so that you can then run parallel user lands, right? Now, the Docker runtime itself is more tailored towards manual starting and destruction of container images, manual changes, manual interaction, right? Not deterministic interaction, right? Deterministic, it is deterministic in the sense that you're always running the same image, but not actually the setup and how these things are started. In the cloud world, some tools exist to help solve some of those problems, right? Things like Docker Compose, Kubernetes, whatever. Like, there's all kinds of orchestration tools out there, right? In the embedded world, container orchestration is a lot more, let's say, early. It's a little bit more baby steps, right? We decided to use LXC because we're not using the whole of the stack of LXC for actual CLI or control of containers. We're rather just using it as the C library for it. It was the simplest, let's say, most lightweight manner that we found to interact with Linux namespaces, C groups, and so on at a higher level, right? while still doing it with just a C library that was license permitting for our use case, right? This is what allows us to, of course, within less than 1 megabyte of footprint, realize an entire system that can power everything I just said, right? All the way from containerized software modules running, your secure boot strategy, storage strategy, encrypted disk strategy, everything that is needed to truly assemble a modern embedded Linux system, but like a proper application-based modern embedded Linux system, right? With a footprint of less than 1 megabyte, right? We strive for that back in 2016, because originally our target was and this is me diverging a little bit. You stop me if you need me to shut up.
No,
right?
no, it's great. It's great.
We started in 2016 with the intention of bringing this technology to the telecommunications ecosystem, in particular routers, right? So in fact, we still have some around here in the office. Routers are just embedded Linux systems that we very well know. They will use some kind of derivative of OpenWRT or Lady or whatever, or any of the iterations and names that it has gone over, right? So we brought, an application model based on Pantavisor with containers and the ability to change your firmware in a much more modern way to that world. What we didn't realize at the time is that world did not have any extra space for OPEX on top of what the telcos were already doing, right? The squeeze was complete. So it was relatively hard to bring a new services model to that world, right? However, I think it was good that we targeted that world early on, because at the time, those routers were maybe like 1632 megabytes of RAM, right? 1632 megabytes of ROM, of flash, right? Of NOR flash. And that truly funneled us into making the system as tiny as can be and as constrained as could be, so that we were ready to support all kinds of embedded devices now, right? I think most of the embedded devices we support at the time now are, where your typical 128 megs of flash, 256 megs of flash, that type of range, right? Which for us is massive, really. But what we end up seeing is that it's the fact that we now bring application architectures to our customers makes them a little bit more, wasteful, accidentally wasteful, right? Because they start, like, okay, well, I'm going to build these different applications, and now I can deploy many things on the system. And even though we're still talking about like small containers, we're talking about like 2, 3, 5, 7 megabyte containers here and there. It starts to get, like the ideas start flowing with the customers, and they just create too much, right? But that's a good thing. It's a good problem to have, right? Because it gives them the ability to evolve their products at a speed, at a velocity that was just not possible 10 years ago, right? 10 years ago, it was very monolithic. Every deployment was siloed, especially for the companies that have, hundreds of different product lines powered by hundreds of different boards, right? It was like every little product was like its own little company inside, right? Yeah. Now what we're bringing to the world is the ability, an analogy I usually use is that in the 90s, Dell, in the early 2000s as well, Dell created what, in my mind, was their true differentiator. They created the made-to-order computer production line, right? It was kind of like when you were, like when you order a car, it goes into a production line and then it gets painted black or blue or whatever. Well, Dell did that, right? You would make an order and it would assemble with the parts needed, and it would just like funnel them out, right? What we're doing here is we're extended that same concept to the embedded industry, to the point that now, big companies that have hundreds of products can base them on a much lesser amount of baseboards, right? And can push those baseboards as just another one of the hardware components that go into the machines. And the software itself just becomes also part of the BOM for those machines. If you can mix and match the boards that go in there and the software components, I need this container, that container, and that container, networking, security, software updates, computer vision, for example, then you can really achieve a velocity that was just not possible a few years ago. And that's what we see with our customer base at the time, right?
Yeah, cool. Yes, very nice. So you already answered my last question a little bit, but I want to ask you about what was the motivation when you was at Canonical. I think you met Alexander there. I don't know if you met him earlier. What was the motivation and the opportunity you guys see to start Pantacor and develop Pantavisor and so on?
Well, we saw at the time that the companies, including Canonical, they were trying to take a very vendor lock approach, let's say, right, to the problems of embedded Linux at the time, right? They were trying to take a very cloud-centric vendor lock approach to it. And we thought that actually there was a huge opportunity in what I said, the even smaller embedded segment. Like that's why we targeted a telco, right? Because telco was completely outside of the target scope of the big Linux vendors, right? Like Canonical, Red Hat, SUSE, whatever. They were all thinking about their own solutions at the time. And we said, okay, well, we really need to go attack the truly small segment of the market because that's where the massive volume is. And there was just no solution for that was complete open source, right? You had hundreds of consulting firms that were doing things on top of OpenWRT for all the telco industry, but you didn't really have a solution to update machines in a way that was better than sysupdate at the time, right? To update routers at scale in the field, right? I think what we did back then was a little bit ahead of what the industry needed at the time, right? And we're actually seeing much better traction in the last 3 years than we did, 8 years ago, right? But yeah, the real motivation was that one. It's like there is no single complete open source stack, both on the device side, on the cloud side at the time in 2016, that you could use across the industry, all the way from 16 megabytes of RAM devices to gigabytes of RAM devices, right? That just didn't exist. And what also didn't exist was a solution that was OS agnostic, that no longer cared about the distribution, right? Back then, the distribution fight between Ubuntu, SUSE, Red Hat, whatever was big. But in the embedded world, that has never truly mattered, right? So we say, like if anything, people build their own distributions all the time with all kinds of tools. Back then, it was a little bit more, tinker stuff. Now it's more Yocto, Open Embedded, all these kind of things, right? Or OpenWRT in the middle. There's always been, distribution building tools. What we bring on top of that is a productization tool, right?
Yeah.
You're building your distributions right now with a Yocto, with an OpenWRT or whatever, taking it one step further to productize that into a manageable product at scale, at million device scale with fully open source software. That's what Pantacor does, right?
Okay, great, cool. I don't know if Fabio, Thiago, wanna fill in.
Thank you very much, Ricardo. Let's go to the chat here and see what people said, what people comment.
Okay, let's see if we have some questions, but I think no.
We have a comment here from Vinicius.
Okay.
Containerization is a great tool to facilitate application upgrades over the air in embedded devices without the need to send and flash the full device image. But you have to take care and do the right thing, right, Ricardo?
Absolutely. I mean, but that's what we do, right? I mean, we make it straightforward for individual container objects to be versioned and cycled on the device. And this opens the doors to many things. For example, you can actually update parts of the device stack without rebooting a device, right? I mean, it might sound obvious, right? But that ends up being very powerful in the long run, right? Like if I need to, let's say, update the graphics stack on a washing machine, right? Then if it's not being used, maybe I can send an update without having to reboot the whole device, right? Or a fridge. A fridge, maybe it's a little bit more important because the fridge needs to cool all the time, right? So if I need to do that, maybe I just update that part. If I need to update the connectivity module of it, well, I just do that container, right? Of course, maybe if I need to update the part that actually controls all the compressors and so on, maybe that one needs to reboot because it needs to make sure it can start from a full cold start, right? So it really brings those, let's say, a quality of life improvements to both the developers and the operators of this fleet of devices. especially when they become more and more complex, right? Because now we're talking about a fridge that maybe is no longer just a fridge. It also has a screen, it has some cameras, it has some sensors, it talks to the cloud, right? So you need to all of a sudden start updating individual parts more often. Security becomes the thing, right? If you're talking to the internet, then security is important. You need to be able to, okay, well, I'm talking to a cloud system over here, it's exposed, this port, a service is running over there, and maybe every 3 months there's a CVE for it, and you need to update it every 3 months, as simple as that. That didn't happen before when things were not connected. So, before maybe we were updating something twice a year or once every 2 years, if we're talking of a router, right? And then after 5 years, it was going in the bin, you were getting a new one. Now your fridge is maybe updating 3-4 times a month, and you don't even know about it, right?
Yeah. There's one thing to add. So one thing I see in Pantavisor, I think is very cool, is we treat the BSP, kernel, device trees, and so on, as a container. So kind of like a container, you can upgrade that. So I think this is very cool.
Exactly. It's not containerized in the sense that it's not part of the tools used for userland, like namespaces and so on, but we treat it as also a component in our system state that can also be plugged out and in and revision and updated, right, in a transactional manner, the same way as the containers themselves, right? Of course, that involves logic and the boot process and everything, but it's a logic that is widespread and is very homogeneous across our supported devices stack.
Okay, Ricardo, you worked on Canonical a long time ago, and we have here, I don't know if it's true, it's joke from Robert. Ricardo is the guy who came up with the name Ubuntu.
Of course not, absolutely not. I don't know. I mean, I would imagine it was Mark, right? But maybe he tells you actually it came up in some weird day, who knows what, right? But
thank you,
I would put
Robert.
that one on Mark.
Okay.
Thiago, can you read this question from Rogério?
Yes, Rogério Silva. How would security work, for example, using TPM chips in the container? I believe it's not as straightforward as when we use them on native OS.
Actually, on the contrary, it's even more straightforward, right? Because of what I was saying before, right? I touched on that earlier, like half an hour ago or so, on the security question. Because all of our system is architected as, let's call it blobs, right? These blobs being the containers themselves or the BSP components, we can actually use a TPM to measure each forward step in a much more controlled manner, right? We have to measure maybe only like 6 or 7 things, all the way from a root of trust to the running userland of each and every one of the containers. Whereas in a normal native OS mode, then there are different ways of how you measure everything that gets loaded in the loading chain, but you're handling a lot more device accesses, file accesses, and so on, right, that are being loaded into memory. So it's a little, I think that for a deterministic embedded device driven solely with Pantavisor, then the fact that you only need to measure your bootloader, your kernel image, your initRD, and the container images below it, make it straightforward to use something like a TPM or your different crypto chips that you have on NXP or the TI, different architectures, right? They all have their somewhat solution for it, right? And we have support across the board for some of the most used cases, especially with NXP.
Okay, thank you. That's it.
Okay.
Thank you, everyone that brings comments here to our chat. Thank you very much, Ricardo, for being here this time on Spain. Are you in Spain, right?
I am, yes, I am in Spain. It's a little late, but it's okay, it's fine.
It's hot. It's hot.
It's also very hot, yes. It's actually, so here in the office, they turn the AC off when everyone leaves. So I'm also melting.
Oh,
right? Yeah.
Here's freezing.
Here's freezing. Yeah.
Well, there you go. Over here is really hot. But hey, guys, thank you for having me. For sure, absolutely, it's fantastic. As I mentioned before, I'm always happy to talk to the embedded Linux community in Brazil. Like I've always had positive experiences with the embedded Linux community in Brazil. Robert Wolf can also attest to that. I have many friends in the world over there, right? And thank you guys. Always happy to be here. Right?
Thank you very much. Fernando?
Yeah, thank you guys for everybody, for everything. Thank you, Ricardo, for staying with us so late. With you.
No worries. And I also wanted to say, we will certainly look closely into everything else that Embarcados is doing, right? Because we're really excited about, your projects over there, and hopefully we can collaborate further, right?
Yes, of course.
Now, Ricardo, we are going to give the last words here in Portuguese, but it's going to be very slow for you to understand.
Ok, thank you.
Então, pessoal, então, vamos convidá-los aqui para o Seminário Linux Embarcado 2025, que é um evento online que acontecerá no dia 30 de agosto. Tá aí embaixo aí na legenda, tá? A gente vai deixar o link para vocês aqui no chat. A gente pede para vocês também divulgarem, ajudar a gente na divulgação. São 7 palestras nesse momento e a gente está trabalhando aí para trazer mais palestras ainda para o evento. Teremos diversos kits que iremos sortear também durante esse evento. Então, gostaríamos que todos participassem. E tem também o curso de Linux Embarcado que o Fernando e a Bruna acabaram de publicar todas as aulas e publicaram também o desafio essa semana, não é, Fernando?
Sim, a gente deixou um desafio para o pessoal fazer. Então, já tá... O curso está completo, né? E aí tem um desafio que daqui, acho que um mês e meio, mais ou menos, a gente tem a resolução e a gente vai ver quem que elaborou o melhor desafio, né, o projeto, então ficou bem bacana.
Ô Fernando, em 30 segundos, que desafio é esse? Conta pro pessoal aí.
Bom, o desafio é aplicar o que o pessoal conheceu no curso, então é fazer um sistema de controle de acesso, então a pessoa usa um RFID, né, um leitor de cartão de RFID, e aí ele vai fazer uma aplicação em LVGL no display, né? E aí tem todas as lógicas, a gente lê algumas IOs, tudo que a gente viu no curso vai estar lá.
Muito bom, muito obrigado. Muito obrigado por trazer esse conteúdo aqui, inclusive com containers e diversas informações novas, LVGL, né? A gente nunca teve aí no curso de Linux aqui no Embarcados. Muito obrigado.
Beleza.
É isso aí. Fábio?
Seguinte, pessoal, rapidinho. A conversa não acaba aqui com o Ricardo. Coloquei para vocês o LinkedIn dele, tá? Também o LinkedIn da Pantacor. Vocês têm que seguir lá, eles produzem bastante conteúdos. E aí vocês acompanhem lá para vocês fazerem projetos aí, né, usando as ferramentas, tá? E para quem não entendeu tudo aqui a conversa, no YouTube, depois o YouTube passa um tempinho e coloca a legenda, tá? Então, fiquem tranquilos em relação também a pegar todo o conteúdo, voltem aqui no vídeo, tá? E assistam com legenda. Beleza? É isso, em breve a gente vai chamar mais o Ricardo aqui para fazer, né, ou talvez outras apresentações mais voltadas para as ferramentas. Então, fiquem à vontade também a pedirem conteúdos também, tá? A ideia é que a gente leve o conteúdo que ajude vocês aí da comunidade a desenvolver os projetos. Thank you!
Thank you, Ricardo.
Thank you, Ricardo.
Thank you, guys. Have a good rest of the day. Bye-bye.
Yeah.
Bye-bye.
Bye-bye.
And Robert is here on the chat. Thank you, Robert.
Robert.